Google just released a model with 2 million token context. Anthropic pushed to 1 million tokens. OpenAI is at 128K. These numbers sound impressive, but here's what nobody's asking. What does 2 million tokens actually let you do that you couldn't do before? Because context length has become the new benchmark war. Every major AI lab is racing to bigger numbers. But unlike parameters or training compute, where more is clearly better, context length has a threshold problem. There's a point where it stops being a capability unlock and starts being a solution looking for a problem. In 2023, most models had 4,000 token context windows. That's barely enough for a long email thread. Today, Gemini 2.0 Flash handles 2 million tokens. That's 3 full novels, an entire codebase, 50 hours of meeting transcripts. But the real question isn't what fits in 2 million tokens. It's what you can actually accomplish that justifies the compute cost and latency penalty. In this video, the evolution from 4K to 2 million tokens, what actually fits in these massive context windows, the real use cases versus the hype, why cost and latency matter more than the headline numbers, and when you genuinely need long context versus when a shorter window with better retrieval is the smarter choice. This is the capability that MIT's breakthrough list missed as a standalone category, but it fundamentally changes how we build AI applications. Let's start with where we were. In early 2023, GPT 3.5 had a 4,000 token context window. That's roughly 3,000 words, enough for a short document, a code file, or a brief conversation, but not much more. Claude 1 launched with 9,000 tokens. Better, but still constrained. Then the race began. GPT-4 launched with 8K standard, 32K extended. Claude 2 jumped to 100K tokens in May 2023. That was the first time you could fit an entire book into a single context window. Anthropic called it the equivalent of about 75,000 words. Developers started experimenting. Could you analyze a full codebase, summarize a 100-page research report, query an entire legal contract without chunking it? By late 2024, the numbers got extreme. Gemini 1.5 Pro hit 1 million tokens in February. That's roughly 750,000 words, multiple novels, an entire codebase for a mid-sized application, 50 hours of meeting transcripts. Claude 3.5 Sonnet went to 200K standard context. Then in December 2024 and January 2025, Gemini 2.0 Flash pushed to 2 million tokens. That's 1.5 million words. At that scale, you're not talking about documents anymore. You're talking about entire knowledge bases. But here's the critical question. When you double context from 1 million to 2 million tokens, what new capability do you actually unlock? The technical challenge scales non-linearly. Attention mechanisms in transformers have quadratic complexity. That means doubling context length quadruples the compute required for self-attention. A 2 million token context isn't twice as hard as 1 million. It's exponentially more expensive, which is why the models that achieve this use architectural tricks. Sparse attention, local attention with global tokens, ring attention for distributed processing. Gemini uses a combination of these. The result is that 2 million token context is technically possible, but it's slow and expensive to run. A single inference pass with a fully loaded context can take minutes and cost dollars, not seconds and cents. That's not a limitation for every use case. So what are the genuine use cases? The first is comprehensive codebase analysis. With 2 million tokens, you can load an entire application source code and ask cross-file questions. Where is this API endpoint called? What would break if I change this database schema? Find all the places this variable is mutated. Traditional code search tools grep for patterns. Long context models understand semantics. They can trace dependencies, identify architectural risks, and suggest refactoring opportunities. That's a real unlock. You can't do that with Retrieval Augmented Generation because RAG requires you to know what to retrieve. With full code-based context, the model sees everything. The second use case is multi-document synthesis. Legal due diligence is a perfect example. A merger might involve hundreds of contracts, regulatory filings, and internal memos. Traditionally, lawyers read each document separately and manually cross-reference. With long context, you can load 50 contracts and ask, are there conflicting non-compete clauses? Which agreements have change of control provisions? Summarize liability caps across all vendor contracts. The model can synthesize patterns across documents that would take human analysts days to find. Investment research is similar. Load all quarterly earnings call transcripts for a company and ask trend questions. Load competing companies' 10Ks and compare strategies. That's not hype. That's a workflow transformation. The third use case is long-form content understanding. Customer support is an example. Load 6 months of support tickets and ask, what are the top 10 feature requests? Which bugs appear most frequently? How has user sentiment changed over time? You can analyze themes, identify product gaps, and surface insights that get lost in ticket-by-ticket reviews. Research synthesis is another. Load 20 academic papers on a topic and ask, what are the areas of disagreement? Which methodologies are most common? What gaps exist in the literature? These are tasks where the value comes from seeing the entire corpus at once, not retrieving fragments based on keyword similarity. But here's where the hype starts. Long context is often marketed as a replacement for Retrieval Augmented Generation. The pitch is, why chunk documents and retrieve relevant pieces when you can just load everything? The answer is cost and latency. RAG with a vector database lets you retrieve the 5 most relevant chunks out of 10,000 documents in milliseconds. Long context with 10,000 documents loaded means processing millions of tokens per query, taking seconds or minutes and costing dollars. For most applications, RAG is faster, cheaper, and good enough. Long context is better when you need cross-document synthesis or when retrieval would miss important connections. But it's not a blanket replacement for RAG. It's a different tool for different problems. Let's talk about the economics. Context pricing is usually linear. If a model charges $3 per million tokens for input, then a 2 million token context costs $6 just to load, before you even generate a response. Add output tokens, and a single query can easily cost $10 to $20. For comparison, a typical RAG query with 5 retrieved chunks might use 5,000 tokens total. At the same $3 per million rate, that's 1.5 cents. That's a 400x cost difference. For consumer applications or high-volume enterprise use, that math doesn't work. Long context makes sense when the value of the insight justifies the cost. Legal analysis, where a single overlooked clause could cost millions, worth it. Customer support chatbot answering 1,000 queries per day? Absolutely not. Latency is the other hidden cost. Attention complexity means that processing 2 million tokens takes time. Even with optimizations, you're looking at seconds to minutes for a response, not the sub-second latency users expect from modern AI. That's fine for batch processing. Run an overnight analysis on all company documents. But it doesn't work for interactive applications. A user asking a question and waiting 30 seconds for a response is a bad experience. Which is why most consumer AI products still use shorter contexts with RAG. The speed-quality trade-off matters. A fast, good enough answer beats a perfect answer that takes a minute to generate. There's also a practical limit to how much context a model can effectively use. Just because you can load 2 million tokens doesn't mean the model attends to all of it equally. Research shows that transformer models suffer from lost-in-the-middle problems. Information buried in the middle of a very long context is often ignored or weighted less than information at the beginning or end. So you might load 50 documents, but the model might effectively focus on the first 5 and last 5 and skim the middle 40. That's not a fatal flaw, but it means that loading everything doesn't guarantee the model will use everything. Smart chunking with retrieval might actually give you better results by ensuring the model sees the most relevant information in a shorter, more focused context. So, when do you actually need long context? The clearest case is when retrieval fundamentally can't work. If you need to analyze patterns across an entire corpus and you don't know in advance what's relevant, long context wins. Example: compare the writing styles of 3 different authors across their complete works. You can't retrieve relevant chunks because the relevance is the aggregate pattern, not specific passages. Or identify architectural inconsistencies across this entire codebase. You don't know which files are inconsistent until you see all of them together. These are tasks where the insight emerges from holistic analysis, not targeted retrieval. That's where 2 million token context unlocks something genuinely new. The second clear use case is when context itself is the competitive advantage. If you're building a product where the value proposition is, we analyze your entire knowledge base, then long context is a feature, not just a back-end optimization. Legal AI that promises to review all contracts simultaneously. Code analysis tools that guarantee they see the full application. Investment research platforms that synthesize across every quarterly report. In these cases, you're selling the comprehensiveness. Users expect it, and the cost is built into the business model. But for general-purpose assistance or consumer applications, shorter context with smart retrieval is still the better default. The third case is when you're doing research or strategic work where speed doesn't matter, but comprehensiveness does. If you're a researcher analyzing 100 papers to write a literature review, spending 5 minutes for a comprehensive synthesis is fine. You're not doing this 1,000 times a day. You're doing it once, and the quality of the output determines the quality of your work. Same for strategic planning. If a CEO wants to understand competitive positioning across all market intelligence reports, a 10-minute wait for a thorough analysis is acceptable. The use case is batch, not real-time, and the economic value of better insights justifies the cost. This is the zone where long context shines. Low query volume, high insight value, batch processing acceptable. Looking forward, context windows will keep growing. Gemini 2.0 Flash is at 2 million tokens, but the next generation will likely push to 5 or 10 million. At that scale, you're talking about entire corporate knowledge bases in a single context. Every email, every document, every Slack message. The technical question is whether attention mechanisms can handle that effectively. The business question is whether it's cost-effective compared to smart retrieval. My bet is that we'll see hybrid approaches win. Most queries will still use RAG for speed and cost, but when you need comprehensive analysis, you'll dynamically expand to long context for that specific task. Think of it like zoom levels on a map. Most of the time, you navigate with a zoomed-in view, but sometimes you need to zoom out to see the whole territory. Long context is the zoom-out capability. Here's the practical takeaway. Don't build your application around long context just because it's available. Start with the default, shorter context windows with retrieval augmented generation. It's faster, cheaper, and works for 90% of use cases. Use long context strategically for tasks where you genuinely need cross-document synthesis or holistic analysis. And track your costs. A feature that costs $10 per query needs a business model that supports that. If you're building enterprise software for high-value workflows, long context can be a differentiator. If you're building a consumer chatbot, it'll bankrupt you. The capability is real. The hype is also real. The discipline is knowing when to use which tool. One more thing. Context length is a technical capability, but it's not the only dimension that matters. A model with 1 million tokens of context that actually uses all of it effectively is better than a model with 2 million tokens that suffers from attention dilution. Similarly, a model with 128K context and excellent retrieval integration can outperform a model with 1 million tokens and no retrieval. Don't optimize for context length as a standalone metric. Optimize for the system design that solves your problem at acceptable cost and latency. Sometimes that's long context. Often, it's not. And that's fine. The best AI applications are the ones that use the right tool for each job, not the ones that use the most impressive sounding numbers. Long context AI models are a genuine capability advancement. Going from 4,000 tokens to 2 million tokens in less than 2 years is impressive engineering. And there are real use cases where long context unlocks something fundamentally new. Comprehensive codebase analysis, multi-document legal synthesis, strategic research across entire knowledge bases. These aren't hype, they're workflow transformations. But context length is also the new benchmark war. Every lab is racing to bigger numbers because bigger sounds better. The reality is more nuanced. Cost scales, latency scales, attention quality degrades. And for most applications, smart retrieval with shorter contexts is still the better choice. The discipline is knowing when you actually need long context versus when you're using it because it's available. If you're building for high-value, low-volume workflows where comprehensiveness is the differentiator, long context can be a competitive advantage. If you're building for consumer scale or real-time interactions, it'll destroy your margins and frustrate your users. The future isn't everything uses maximum context. The future is smart systems that dynamically choose the right context window for each task. Zoomed in for speed and cost, zoomed out for synthesis and strategy. That's how you build production AI that actually works at scale. If you're building AI applications and trying to figure out when to use long context versus retrieval augmented generation, here's a resource. I've written a decision framework that walks through the cost, latency, quality trade-offs for different use cases. Link in the description. And if you found this breakdown useful, this is part of the Key Advances series where we go deep on AI capabilities that are changing how systems get built. Subscribe for more technical deep dives without the hype. We will continue to cover the AI and related topics on this channel. If you have not already, hit that like button and ring that notification bell. In this way, more and more people will have access to this valuable research. See you in another video.